Whether you talk of small thing or big thing, gas or liquid or solid, everything is matter. What is the physical nature of matter? Matter is made of particles. How do we prove that matter is made of particles? You can look at a simple activity. You know that in market, sugar is available in different forms. There are crystals, big cubes of sugar. There are small also cubes of sugar, quite small. If you take some water and dissolve these two types, the ones having big crystals and the one having very small crystals, and then you mix well, then the end result is going to be almost similar. Whether big or small, cubes will be gone. Now that proves that no matter how something can look like, eventually you can get it in the form of very small particles. So matter is made of particles. Now the question comes, how small are these particles? If you look at something like potassium permanganate and dissolve it in some amount of water, you can see some color. That color is due to potassium permanganate. Let's say you have a beaker in which you have got some water. In that you have added potassium permanganate and mixed well, and you are seeing some color. Now from that sample, take only little bit and take a fresh beaker with water in it. Take that little bit and add it in that fresh water. Again mix it. You can still see the color. Then from that which was diluted, take little bit, take fresh water, add that. So you are diluting it further and further and further. In spite of doing this several times, you can still see there is color. Yes, darkness may become less. It may become lighter the more and more and more times you do this process, but still you can see the colors in spite of taking so many water samples. So what are we trying to understand is that the size must be so small that no matter how many samples we are making, these particles are able to reach there. These particles are able to reach there. That's why we are noticing some different color, different from the color of the water, natural water. Instead of color test, one can do another type of test also which relates to the smell. Something like Dettol. You take little amount of Dettol in some beaker with some water in it, and then from that you take some sample, take it in fresh water. No matter how much dilution you keep on doing, you can still smell Dettol. That shows that particles must be really, really small. You don't see them with your naked eyes, but you see their effect. Overall effect you see. You don't see one individual, you may not see one individual particle, but you see their overall effect either visibly or via some smell change. So particles are very, very small in size. How small they are? Well, later on we will be talking about atom. And even if you talk about atom, you cannot visualize the size, even when you are talking about atom. And atom itself is made of some particles. So just imagine, atom is something whose size you can't imagine. Then if I say that atom is also made of some smaller particles, then just think about imagining their size, those things that are making the atom. And you must be hearing that some experiment is going on in the world in which particles are even crashed so as to get smaller particles of these particles. These particles could be so small that we don't see them, and there are experiments to thrash them further and get even smaller particles, right? So the size is something that is beyond imagination basically at this point of time. That is talking about the smallest. You keep on breaking and breaking and breaking and breaking and breaking. Where do you reach at the very end? So at this point, all we can say is that particles are very small, too small for a human imagination. All right. So we said that there are different forms possible: solid, liquid, gas, small, big. They're all matter, and whether they look small or big, you can have broken them into very small size. So things are made of particles, and those particles at the very end could be too small for imagination at the very end. Next thing is characteristics of particles. Okay, before that, any questions? If you have, then let me know. All right. Characteristics. Particles have space between them. Particles have space between them. Well, I talked about one activity, adding sugar to water and mixing that well. When you do so, you take, let's say, one tumbler of water and you add sugar and mix it well. After that, you take 1 spoon from the top, let's say right side, towards right side of your tumbler. Or you take 1 spoon from the left side of your tumbler. Does it really matter when you taste it? Doesn't matter. That means that sugar particles have gone between water particles because the taste is sweet. Otherwise it was just water. How could it be sweet? So sugar particles managed to squeeze between the water particles. If there were no gap between water particles, then how could that thing taste sweet? Particles have got gap. Now, another characteristic is that particles are moving continuously. Now, how does one say that particles are continuously moving? Take a beaker, in that you have some water, add a drop of ink and watch it. You will see it traveling. It won't stay, but you can see it traveling. Just in a room at a corner, keep a perfume bottle. Just keep it open, that's it. No need to even take out the perfume from it. Just keep it in a corner. After some time, you can smell perfume from the other side of the room. Who asked perfume to come out, go to the air, travel the distance, and reach the other side? Nobody asked. That's the nature. Particles just keep on moving. We may see or we may not see. We don't see perfume particles traveling in the air. But sometimes you can see, like for example, agarbatti. That you can see when those particles travel. If they are dense enough, you can see. Sometimes you see, sometimes you don't see. In fact, when we look at the solids also, that is something we can't see. We don't see, humans. Inside the solids also, there are some vibrations at very small level. So normally we would think that solid is absolutely rigid. Solid as a whole doesn't seem to be vibrating. Imagine a book kept in front of you and it vibrates. That doesn't happen, normally speaking. But what is inside those solids? There is some vibration in them also that we don't see because it is very, very little. Those vibrations are very, very little. So the summary is that particles of matter are continuously moving. Sometimes we may notice that, sometimes we may not notice that immediately. Then, when we are talking about characteristics, we talked about particles of matter having space between them. We talked about particles of matter are continuously moving. Now, another characteristic is that particles of matter attract each other. Particles of matter attract each other. If you just see, practically speaking, you have a tap from which water is falling down. You can see it. It looks like water particles are together. Now, if you just take your hand, you can cut it, right? But after cutting it back, original shape is back. So there is something due to which water particles are together. Or why don't they just fly away from each other? So particles attract each other. In fact, why do we have solids at all? Why do we have liquids at all? Otherwise, there should only be gases, just like air. You don't see anything in the air. It's just not visible to you, those particles which are here and there. They're just flying here and there. Liquid means you can hold it in a container. You can see it, say water for example. So why is water water? Why is not water like just air? Or solid, why is it solid? Why can you hold it? Why can't you hold nitrogen gas which is in front of you and which you are breathing along with oxygen gas? It is because in case of liquid, particles are attracting each other strongly. And that's why they are together closer and closer and closer. In case of gases, in front of you there are gases. They are far away from each other, particles. They don't pull each other strongly enough. In case of solids and liquids, particles are able to pull each other much more strongly than it is so in case of gases. In case of solids, it will be too much force that particles exert on each other. In case of liquid, it will be more than gas, not as much as it is in solid. Solid you just can't cut with your hand, generally speaking. Like water stream you can cut, not so in case of solid. So such forces between particles are strongest in solids, then comes liquid, and the worst case is that of gas. In case of gas, particles are just flying here and there. They are just going away from each other here and there. Now why is it so? If you think, then you have to look into the physics, basically, physics aspect. You have got charges attracting and repelling each other. That property you must be knowing from your personal experience, like a comb attracting a piece of paper. So there are two types of charges, positive and negative. And when we talk about particles, particles have got such things in them having these types of charges. So whatever interaction I'm talking about, particles attract each other. Whatever I'm talking about, it is actually due to the same reason that explains how a comb attracts a piece of paper. It is all physics basically. Electricity, attraction between opposite types of charges type of thing. So, talking about characteristics, particles have got space between them. So a foreign particle can come, right? And then particles are continuously moving here and there. Particles attract each other. And that is why we have solid, liquid and gas as three different phases. If you have any questions, then let me know. We will be talking much more about the states of matter later. But anything else you have to ask up to this point, let me know, or I will put up some questions. So then I'm giving you some questions. All right. What do you think? Let's begin with chair. Yes. All right. Air. Air. Air has got mass also. Air has got volume also. If anybody has any question, just ask at that very moment. Love. Is it matters? No. It is emotion. Smell. You smell something because there is matters, but smell itself is not a matter. Smell is a sensation which is due to some matters. Hate. No problem with that. Almonds. Okay, no problem with that. Thought. Thought is not an object. Cold. That's a sensation due to some matters. Cold drink. Cold drink is matters. Smell of perfume. Well, smell of perfume is due to perfume. Perfume is the matter, not the smell. Any questions in these? Let me know. Fine, so we move on. What do you think could be the reason for this?
The point is that in hot food, the particle vibrates so much that some of the particles are actually kind of beaten away from the food. But in cold food, the particles vibrate very less. So that's why they aren't pushed away from the food, and there's not much diffusion occurring. So that's why you have to go close to cold food for smelling it properly.
Hot. In case of hot sizzling food, the diffusion would be much faster. Any other explanation? And those who are not familiar with the word When you have gas in a room or air in a room and some gas is traveling, then that is called diffusion. Yes, any other explanation?
If there is hot food, the object expands, so many particles escape from the food. So that's how you smell it. Easier in hot food.
Sir, also in hot food, the particles have more energy and they can move faster.
All right. So basically two things. Generally, if you have hotter water, then it would evaporate faster. Rate of evaporation of water is faster when it is hotter. And hot food means water is bound to be there, and water would evaporate. And along with it, those particles responsible for smell, they will run away. Point number two is that there is something called kinetic energy. A moving object has got kinetic energy. Speed, let's say, higher speed. Kinetic energy is higher if speed is higher, generally speaking. So, if temperature of the gas is high, then speed at which particles travel, that thing is high. So these are the two aspects that you can consider while giving the answer. Rate of evaporation and hot things travel more quickly in air, or hot gas travels more quickly in air. If you have any questions, then let me know.
Like particles of matter stick each other.
Can you repeat?
So it shows that particles of matter stick to each other. They stay knotted together, sir, at the same time.
So basically you are saying the particles of matter stick with each other or they attract each other. Okay. Anything else or any other answer?
So this shows that attraction in water is not very strong, so the diver can cut through the water.
Okay, I guess you will have to repeat.
So this shows that the water molecules cannot attract each other with more force, so it is easy for the diver to cut through them.
Okay.
In water, the force of attraction between the particles is less than that in solid. So that's why the diver can cut through water.
Perfect. So particles are attracting each other, but in case of water, this is not too strong, so diver is able to cut through water. Now tell me one more thing. Doesn't it also show that particles of matter have space between them? Yes? Space also, right? If there were no space, what would happen? The diver would hit it and feel terrible pain, not able to enter at all inside water if there were no gap at all. This should be easy.
The particles of matter have space between them.
Yes. Then
Particles of matter are continuously moving, and
Fine.
particles of matter attract each other.
perfect. These three are the characteristics. All right, let's proceed further now in theory. Let's now talk about the states of matter. First, solid state. Something that you can just hold in your hand without any container. Without any container, something that you can hold. Definition-wise, we would say there should be definite shape, distinct boundary, fixed volume. Definite shape, distinct boundary, fixed volume. This is under normal conditions, not that you are applying enormous force and you are saying some of these points has been violated. Say for example, you take a rubber band and you stretch it enormously and you say, I have made it 1.5 times or 2 times. Not under external conditions. Normally speaking, without any external force acting, definite shape, distinct boundary, fixed volume. So that's about solid. You know so many examples that belong to solid. Generally speaking, solids do not compress, generally speaking. Now, should sponge be considered as solid? Sponge can be compressed rather easily. Should it be considered as solid? The answer is yes. Yes. Some types of balls can also be compressed quite a bit. There are many instruments using which we do exercise. They can be compressed quite a bit. Talking about sponge. Sponge has got holes, and in the holes air is trapped. So when you are compressing a sponge, then air is coming out from those holes, and that's why it is compressed. So that's about solid. When we talk about liquid, water probably comes to the mind first. What about the parameters? Generally speaking, these are not compressible. So you take some water sample in some container, apply force using some piston, water would refuse to compress. Generally, liquids don't like to get compressed. So if they cannot be compressed, then we can say volume is fixed. Volume is fixed. But in case of solid, shape was also fixed. That's not the case with liquid. You can take a different container and pour water, same water in a different container, and you will find that water will just accept that new shape, right? So definition-wise or characteristics-wise, you need to look out for fixed volume, but not fixed shape. Fixed volume, but not fixed shape. So that's the characteristic of liquids. When we talk about the gaseous state, well, we can't talk about shape of gas. Whatever containers you have, gas will just accommodate according to the shape of the container. So we can't talk about shape of gas. Then regarding compressibility or volume, again, we don't really define the volume of gas. Gas can adjust its volume also. So same gas can be filled in a huge chamber, and the same gas can be filled in a chamber which is 1/4 size of that huge chamber. So while we do talk about volume of certain solid, volume of certain liquid, talking about volume of gas makes no sense. Volume of gas is the volume of the container in which it is there. Now, that was about defining these three states. Any questions regarding the definitions? If you have, then let me know. We can also define them by talking about the distance between the particles. I'll be talking about that a little later. Any questions up to this point? Let me know.
Sir, this is slightly away from the topic, but I was reading somewhere that 1 mole of every gas occupies only 24,000 centimeter cubed volume. But as you say, it can expand and occupy a variety of volumes. So how can that be true?
What you are saying is under certain conditions. 1 mole under certain conditions. And those conditions are normal temperature and normal pressure. Only under these conditions the volume will be same for 1 mole of all types of gases. So if these conditions are not fulfilled, then you can use any other container and the same gas can be filled there. These conditions will not be fulfilled in that case. Normal temperature and normal pressure. Normal temperature and normal pressure are certain values of temperature and pressure that are clearly defined. Like, for example, the pressure under which we live, that is called 1 atmospheric pressure. That is normal pressure basically. But what we fill in our car tires, etc., that could be different pressure. That depends on tires, etc. Likewise, this temperature, normal temperature, is quite different from the temperature in which we live. We live at nearly, say these days, 35, 40, 45 degrees temperature. This temperature is completely different from that. So that thing is valid only under normal temperature and normal pressure conditions. This is your assignment question. We stop now.